Welcome to Thursday Dairy Update. This is Kathy Barrett with the Cornell PRODAIRY program, and the PRODAIRY program, along with Eastern Dairy Business, is pleased to be able to offer this webinar series. Today's webinar is presented by Dr. Larry Chase, Professor Emeritus of Dairy Cattle Nutrition in the Department of Animal Science at Cornell University. Today he's going to be giving us an update on phosphorus in dairy herds.
Hopefully we can give you some information that'll be of value to you, and we look forward to your questions at the end. So really what we're talking today is some update on phosphorus because we seem to be getting more questions about where it fits, how it fits, and what the levels should be in rations. I think we know that phosphorus is the most expensive mineral added to your ration. It could be 30 to 50% of the total mineral cost. And usually when we look at a farm and say, where's the phosphorus coming from? Most of the phosphorus coming onto the farm is in feeds. There's a small amount of fertilizer, but most is in feeds. And also, if you happen to be a CAFO herd, phosphorus is the mineral that's being regulated in the CAFO regulations. So why do dairy cows need phosphorus? It actually is involved in more physiological functions in the cow than almost any other mineral. About 80% of the phosphorus is in the bones and teeth, so it's obviously important in skeletal development, tooth development, things like that. It's in every cell in the body. It's part of the ATP system, and adenosine triphosphate, which is involved in energy transactions in the body at the mitochondrial level. And it's involved in acid-base buffering. So you can see it has a wide range of things that it does in the animal, and that's why it's important. So how are the requirements determined? Well, the National Research Council, 2001, which is the most recent nutrient requirement publication, used what they call a factorial approach. And what that really means is they look at the requirements for maintenance, which is really the body weight of the cow. They look at the requirement for pregnancy or gestation if the cow is pregnant. They look at the age of the animal, whether it's growing or not, like a first calf heifer versus a fourth lactation cow. And they look at milk yield. They determine the requirements for each of those four segments, and then they add those up to get the total requirement for the cow. And that gives them the total of grams of phosphorus needed per cow per day. Once they have the requirement, then they have to say, well, when we feed feeds to the cow, it's not 100% available. So they use what they call an absorption coefficient to make an adjustment there. So we still have to have a certain number of grams at the cow level, but since feeds are less than 100% available, we have to feed, say, 1.2 grams of phosphorus to get a gram into the animal. So the availabilities they use are about 64% for forages, 70% for the grain mixes, and the minerals are 30 to 95%. Most of the mineral supplements used are 80 to 95% available. And so those are the things behind how we build the requirements for the dairy cow. So I borrowed this from Dr. Dave Beatty at University at Michigan State. And so this is an example of how a mature non-pregnant Holstein cow at 80 pounds of milk, how the requirements are determined. You can see for maintenance, they come up with 25 grams per cow per day, and milk production is 33. In this case, there's nothing for growth since it's a mature cow, and there's nothing for pregnancy. So this says in the blood, they need about 58 grams of phosphorus per day. If you use an absorption coefficient of 0.72, which is an average of the grains and the forages and the minerals, you need about 80 grams in the ration to provide that 58 grams that the animal needs. So if we look at the requirements, and the NRC expresses them as percent of dry matter, assuming a normal level of dry matter intake, you can see the range for heifers is 0.18 to 0.28. Dry cows you can see the range a little bit lower, but then you can see it's 0.3 to 0.4. And that number is a little in the RC publication, but recent work both at Michigan State and other places, and Tom Overton's work at Cornell, says we need a little bit higher phosphorus in close-up cows than the NRC indicates, and that's why you see 0.3 to 0.4. In milking cows, you can see the range is about 0.3 to 0.44. That 0.44 is for a high-producing Jersey. For high-producing Holsteins, it ends up to be about 0.38. So that gives you an idea of the requirements at the ration level when we look at it. Dave Beatty has put together a simple little thumb rule. You need about a gram of ration phosphorus for each pound of milk produced. So it's a quick way to estimate that if I have 70 pounds of milk, I need about 70 grams of the ration. Or 100 pounds of milk, I need 100 grams in the ration. Quick way to estimate. So what happens to phosphorus when the cow consumes it? Really, it's very simple. There's two choices. It's either contained in the milk that's produced, because there is phosphorus in milk, or if there's more phosphorus in the cow than needed for milk synthesis, it's excreted in manure, and mainly in the fecal portion. So the cow really says, okay, I'm going to use what I need to make milk, the rest is going to be excreted. And this is, again, borrowed from Dr. Dave Beatty, showing the relationship on the bottom axis. If you take the measured intake and subtract the phosphorus in the milk, you can see as that increases, the measured phosphorus excretion in the feces also goes up. So basically what the cow is saying, if you provide more than I need to make milk, I'll just excrete it. So what's the content of some of the feeds we have available? This is some recent data from the Dairy 1 forage lab looking at the phosphorus content of legume silage, corn silage, and grass silage. The middle bar, the gray bar, is the average. So let's just look at legume silage. The average was about 0.35. And if you look at the average plus or minus one standard deviation, which gives us 2/3 of the samples, 0.3 to 0.4 is about the range we see in legume forages. And that fits really well with the requirement of the cow. You can see corn silage is a little bit lower, and grass silage is also a little bit lower. But there's a lot of variation, so that's why on your farm, you still need to analyze your forages for phosphorus as part of your management practices. If we look at the energy sources available, and the red line is sort of the NRC requirement for a high-producing Holstein, you can see that corn grain is lower. The other feeds, hominy, cottonseed, mids, they are higher. So again, if you're trying to select feeds, this gives you an index that some of the feeds, like mids, they could be a really good buy from a byproduct point of view, but if you're tight on phosphorus, it may or may not fit in really well. Protein sources, again, most of these are relatively low, but you can see that the fish meal, meat, and bone meal are very high. And the byproducts, most of these are low phosphorus, except for brewers' grains and distillers, which are a little bit higher. So what feeds are less than 0.4? If our guideline in the ration is 0.4, most of your forages, you can see some of the byproducts, corn grain, molasses, soy hulls. What this really says, though, is when we look at the requirements for dry cows and heifers, there's really no practical way that we can ever feed them at requirements, because almost all the feeds, including your forages, are higher in phosphorus than the animal requirement. We do have the option of milking cows, though, to control phosphorus levels and feed closer to intake. So what do we see when we analyze total mixed rations? Well, this is data from Cumberland Valley Labs for samples analyzed over the last year. And again, a similar pattern. On the left, you have the Northeast. The middle is the average, which is about 0.42% phosphorus. And you can see the range was about 0.36 to 0.46. The Midwest, a little higher, average about 0.45. So the average TMR from the Northeast is still a little bit above the NRC requirements, but they're quite a bit lower than what we saw 10 or 15 years ago. So progress has been made. So in the past, there was a lot of concern about overfeeding phosphorus. And why? Well, safety factor. Very few nutritionists or dairy producers are very comfortable that if we need 100 grams of feeding exactly 100, because the variations occur daily in forages, dry matter intake, and other factors. So the question is, how much above the 100 would we feed? Would 105 be good, or 110, or whatever? So there's always a small safety factor we use relative to the requirements. Secondly, there was a perception that added phosphorus improved reproductive performance. Another one is when you do least cost rations, quite often the byproducts are very economical, but they can bring in a lot of phosphorus. And then some of the pelleted feeds use high phosphorus ingredients to help make the pellets. So these are some of the reasons that we may see higher phosphorus levels in rations than maybe the absolute requirement. So let's take a little bit of look at a couple of research things. We'll look at milk production and some reproduction data. This is a study done at the University of Wisconsin, where they had two levels of ration phosphorus, 0.38, which would be the NRC requirement, 0.48 would be slightly above. These cows were on these diets for 2 lactations, including the dry periods. And you can see when you look at milk production, either for the first lactation animals in red or the second lactation animals in green, there's really no difference in milk production over 2 years. If you feed the requirement level 0.38, feeding above does not gain you anything in terms of milk production. This is another summary of some other trials real quick. And they did another trial at Wisconsin, Wu, in 2001. They fed 0.31 to these cows for a 3-year period, 0.39, 0.47. The 0.31 was a very unusual ration with ingredients. It's lower than we can practically feed. But if you look at the results, milk production, there was no significant difference in milk production, even at the lower level. However, you can see on the right, fecal excretion. As you increase phosphorus in the ration, fecal excretion pounds per day went up. It almost doubled from the lowest value to the highest value. The trial below from Virginia Tech, again, 3 levels of phosphorus, no real differences in milk production. 2 other trials, you'll see the same pattern. You have increases in phosphorus in the ration, but you really see little change and no significant changes in milk production. So all of these trials, and there's lots of others in the literature, say that high-producing cows at greater than 25,000 pounds of milk for Holsteins can be fed diets of 0.35 to 0.4 for 2 or 3 lactations with no effect on milk production. So I think that gives us some pretty good answers on the milk production side, that feeding above requirements is not going to help us in terms of additional milk production. What about reproduction? Dr. Satter at Wisconsin summarized 13 trials, and he ended up with a little over 300 cows for treatment. So these are from a variety of trials, and they just put them into 2 groups for analytical purposes. The group that was fed phosphorus 0.32 to 0.4%, you had about 393 cows, and you can see the days to first estrus, days open, services for conception, and pregnancy rate. Now, this is not the 21-day pregnancy rate. This is another measure of pregnancy rate. Compare that to the column on the right. There's really little or no difference and the reproductive performance of those cows, no matter if they had the lower level of phosphorus or the higher levels. We did some research with the USDA a number of years ago, and this was University of Pennsylvania's lead institution, but Cornell, Maryland, Penn State, Delaware, and Virginia Tech cooperated in the project. It was an observational study. We did not reformulate rations. We just went to herds, found herds feeding different levels of phosphorus, and obtained a lot of information in those herds, but we did not want them to change their phosphorus levels during the course of the trial, which lasted 3 years. Each herd was visited 4 times a year. We took feed, TMR, and fecal samples and had all the milk production data. Herds, there were 94 herds total. We had 29 herds in New York. They went from 50 cows to 2,500 cows. We had both freestall and tie-stall herds, and milk production from 20 to over 31,000 pounds of milk per cow. We had about 13,000 cows in New York. The total project, we had about 27,000 cows we were using in monitoring both milk production and reproduction. So we had 3 groups. The low group is the blue line. They were right at the NRC requirement, 0.35, 0.38. The pink line were slightly above, about 0.42. And then we did find a group of herds that were around 0.5. So we had a good spread of phosphorus levels in the herds. And the other thing, you can see that the herds that started out high stayed high. The herds that started low stayed low for the whole trial. So the herds didn't really cross over between the different groupings. If we look at the data at the end of the first year, again, the left column just breaks diet phosphorus level down less than 0.38, and then the high was greater than 0.45. There's really no difference in milk production statistically. You say, well, maybe it looks different, but statistically those numbers are about the same. If we look at days open, following the same pattern, you can see that when you look at either all cows or pregnant cows, there's really, again, no differences showing in days open. If you look at the pregnancy rate and conception rate, again, you see no real differences there due to phosphorus feeding level. In days to first breeding, again, there's really no differences sitting there. So this was the data from the first year. Look at the data for the 3 years, you get a similar pattern. We did not have much impact of milk production, and there was no real advantage of feeding higher phosphorus levels in terms of reproductive performance. What did happen, as you can see in this, as we fed more phosphorus in the diets, the bottom axis is the grams per kilogram going from low to high. As we fed higher phosphorus diets, we had higher levels of phosphorus in the manure. So the cow was saying, I'm not using the extra phosphorus for milk or repro, so I'm excreting it via the manure.
Larry, can I interrupt for just a second?
Yep.
For a question that came in? The question is, just wondering what dry matter intakes were in these trials, because cows, again, require grams of phosphorus, not percentages.
Right. That's right. So again, these herds, the best we know that intakes were very similar in these herds also. In the NRC, that's when they set the requirements. It actually is grams of phosphorus, and they divide it by a normal intake, and that's how they get percent. So if you look at ration formulation programs that we use, all of them are doing it on a grams basis, but then we're printing out the results on a percent basis based on the intake in your herd. So if you have a high-producing herd and your intake is higher than average, you can actually have a lower percent phosphorus and still get the same grams. However, if your intake's lower than average, you would need a higher level of phosphorus in the ration on a percent basis to get the correct grams. So pretty well all the programs that are used calculate grams, but most of the reports you see then put it in a percent basis for interpretation. But you're right, cows always need grams and pounds, not percents. Okay. So basically, at the end of this study, when we had levels that were basically 100, 110, 123% of requirement, there were really no differences showing in milk or repro, but there was an impact on fecal excretion. There's some additional information that's come along since this, looking at reproduction specifically. A trial fit diets that were 0.35, 0.47. And again, if you go back and look at these rations, you'll find dry matter intakes are fairly similar in these trials between the two rations. So there's no effect, they had no effect on ovarian activity, reproduction, or milk production. Another trial at Wisconsin fed either low or very high levels of phosphorus, and the higher phosphorus levels did not have an effect on the intensity or duration of the estrus, and no detectable effects on reproductive performance. This is a worksheet that was put together by Dr. Satter and one of his students, which is kind of interesting because it shows on the left, and these are the trials that they've done, and again, the intakes are very similar of the rations. On the left, you see intake. So phosphorus intake grams per day went from 60 to about 130. If you look at the grams excreted in milk, it was fairly constant at about 40 in these trials. If you look at the excretion manure, it monitors patterns after the intake. So really, it's the intake minus the milk. The rest is in the excretion. So that's why I think we need to provide adequate phosphorus for the cow for milk production with that safety factor, but then try to minimize above so we don't have a lot going out into the manure, which has an impact on nutrient management. And we'll talk about that in just a minute. This is some data, similar data from Florida, showing just as you would expect. You feed more phosphorus in the ration. Milk production is similar in the herds, intake similar, excretion goes up in terms of the quantity excreted per cow per day. And look at the difference there. Between 0.4 and 0.45, that's almost 8 or 9 pounds more phosphorus per day. The one on the right, I don't think we're going to see herds at 0.6, so we can ignore that. But even a small difference, 0.4, 0.45, you're looking at 7 or 8 pounds of phosphorus per day extra in manure from those groups of cows. So what we did, we said, okay, let's just take some examples from this data set we had from our field study and look at how much is excreted by the cow and how many acres we need to spread the manure on, assuming we can only add phosphorus at 30 pounds of phosphorus per acre, which is really crop removal rate. So we picked data from 3 herds. A herd with a high level of phosphorus, these are all New York herds, mid-level and low. So you can see that the diet phosphoruses range from 0.38 to 0.57. Total phosphorus in the feces measured through the labs, 0.74 to 1.16. So again, as we feed more phosphorus, we tend to see a higher level in manure on analysis. So total excretion, taking into account the dry matter intakes in those herds, a little over 50 pounds per day per cow, about 50 pounds per herd in the high one, and about a little over 30. So there's a difference there of 15 to 20 pounds of phosphorus per day in a 100-cow herd, depending on the ration phosphorus levels fed. What does that mean in terms of the acres if you can only put on 30 pounds of phosphorus per acre needed for those cows from about 110 to almost 180? That's a big difference in terms of potential land needed. Now, if you have soils that are not high phosphorus, and you could put on 40, 50, 60 pounds, that'll narrow the difference between these diets. So the next thing we're going to think about then is nutrient management and whole farm balances of phosphorus. If you look at your farm and you think about it, where does phosphorus come onto the farm? Usually it's in feed is the main source. There may be some in fertilizer. You may get some in bedding, and obviously if you buy animals, there'll be a small amount there. The majority of it, though, is on the feed side. How does phosphorus leave your farm? Exported. Milk is going to be the primary one. If you happen to sell crops, animals, or manure, then those would also be sources of exported phosphorus. What we calculate is the difference. Imported minus exported means that amount of phosphorus remains on the farm, and that's sort of called a whole farm balance. Stu Klausner, when he was at Cornell back in the early 90s, looked at a number of herds and calculated the balance. And the phosphorus balance was 68 to 81%, which says that if 100 grams or 100 pounds of phosphorus came onto the farm, 68 to 81 pounds stayed there. So you can see that if that happens over a long period of time, your soil phosphorus levels are going to be increasing. I see a mistake on the next slide. Corinne Kettering's 2005 looked at 22 herds. The average was 50. So we've made a lot of progress since the early 90s to to 2005. Phosphorus balances of farms have been reduced, I think primarily due to, number one, we're feeding a little bit less phosphorus, and there's been a change in phosphorus fertilization on these farms. So we're going in the right direction. Another one that Dr. Kettering's presented at the Cornell Nutrition Conference 2011 was the amount of phosphorus remaining pounds per tillable acre. And if you look at the data of 2004, it was about 9, and this is on, again, a number of New York farms. 2009, it was down to a little over 4. So again, that phosphorus remaining, the excess, is on the right trend. We're going downward in terms of improving the efficiency of use of phosphorus or minimizing the balance or the growth of phosphorus in your soil resource. So what happens when you go to a real farm and try to put some of this together and see what happens in terms of excretion? And this is a trial that Dan Fox and Tom Taluki did a number of years ago on Easy Acre Farms in Homer, New York, which was then 500 to 600 cow dairy. So when they started, it was about a 500 cow farm with in the low 70s in milk production. You can see the number of animals. The initial phosphorus balance was 67%, which means if they brought 100 pounds of phosphorus onto the farm, only 33 pounds left. The other 67 stayed there in the soil, which would lead to an increased level of the soil phosphorus over time. During the project, which went for 5 years, they did add 100 cows. They did change the ration and use more home-produced feeds, so there'd be less phosphorus imports. They had better yields and quality of forages from the sample. Land base, which lets them feed more forage, obviously. Milk production changed a little, but not very much. So what happened? Well, if you look on the right, phosphorus pounds per year excreted by the herd dropped 28%. So here's a herd that milk production, or milk sold, went up 45%. Nitrogen excretion went down 17%. Phosphorus went down 28%. And purchase feed costs went down 34%. So this is taking sort of the whole package, putting together and saying if we take better advantage of home-produced feeds, which means we buy less imported phosphorus, we lower ration phosphorus to make sure we're at the NRC levels instead of above. This happened, in this case, it was about a 28% reduction in pounds of phosphorus per year in manure that they would have to handle in their nutrient management plan. If you calculate the excretion per cow, and this one they've taken all the manure produced in the farm for calves, heifers, and cows, dry cows, and calculated the number only on the milking cows. So if you take all those animals and say we have this amount of phosphorus divided by the number of milking cows, it went from about 100 to a little under 60. So it decreased significantly during this period of time. Now again, how many acres do you need? Well, if we again go back to the 30 pounds, and that could be, in some of your herds, you can put on more than that. If we use 30 pounds of acre phosphorus manure, at the original level of phosphorus excretion, they would have needed 1,449 acres. With the revised, with the lower phosphorus in the ration, feeding more homegrown feeds, less phosphorus imports, less excretion manure, it was about 300 less acres that would be required for spreading phosphorus at that rate of 30 pounds per acre. So you see it has a major impact on the acres needed to spread manure in a nutrient management plan. Economics. Dr. Satter estimated a few years ago, he was estimating it cost the dairy industry about $100 million a year from overfeeding phosphorus. Catherine Knowlton at VPI, Rick Cohn from Maryland, estimated that a 100-cow herd spends between $800 and $2,500 a year on higher feed costs when feeding phosphorus in excess of requirements. Impact on your profitability potential. You also have to think about the year effect. If some of you remember, a couple of years ago, corn, soybeans were very expensive relative to byproduct feeds. And so in those cases, we saw many herds in New York that went and used a lot of a higher level of byproduct feeds to keep ration costs under control, and that did increase ration phosphorus levels. And so that was a short-term situation that made sense from a profitability point of view in the dairy farm. Now that I think prices have shifted a little bit, a lot of these herds are back to a little bit slightly lower phosphorus levels. So we always have to mix the animal requirement with the economics. When possible, I think we don't need to feed above the requirement, but in that unusual situation, when corn and soy are really expensive, it made sense to use byproducts and have a little bit higher phosphorus feeding rates. So I think if we wrap it up pretty quick, we know that phosphorus is a required nutrient. A lot of research has shown that feeding it above requirements doesn't improve milk and or reproductive performance. Feeding phosphorus in excess of requirements does increase the excretion manure and does increase the crop acres needed for manure spreading. So at this point, I think, I know this is shorter than the hour, but hopefully we got the key points across. And at this point, I think we have probably some questions maybe we can take.
Well, I just went ahead and in the chat box, Larry, and asked if there were any questions. So let's just give folks a moment or two to type in any questions that they have.
But the previous question on grams and pounds is exactly right. Even though we formulate for 80 grams, we usually express it as percent of the ration. So you're exactly correct on that assumption.
So Larry, there is a question here. It says, is there a number, percent, that we should be looking for in manure to help us decide if we are overfeeding phosphorus?
Well, I've not looked at a whole lot of the manure data lately, but if you looked at that study, that limited data we had, it looks like in that study, if we went much above 0.8, it looked like we were excess. But again, we'd have to go back and look at a lot more manure data. We can do that, but usually what we do from a ration point, and we calculate the intake of phosphorus, the milk excretion, and the rest is in the manure, so that gives us an index of where we are.
Okay, so I guess that's the questions for today. Larry, thank you very much for an excellent presentation. Truly appreciate it. Oops, wait, I spoke too soon. There is another question. This question, Larry, is, are there any means of assessing BP availability practically for farm feeds?
Unfortunately, phosphorus availability, there's no practical way. So at this point, what we're doing is using the NRC values, which are building the requirements. We know phosphorus varies between forages. We know that all forages are not 60-some%. But we don't have data, even research data, to show how much that varies. So right now, we're just using the NRC availabilities. We don't have a good measure, either research-wise or farm-wise yet. So that's why the NRC builds those in to their calculations for requirements. Best data they have is what they use.
This is Kathy Barrett again. And on behalf of the PRODAIRY program and dairy business, I'd like to thank you for taking the time to view this webinar.